is actually the area for this parallelogram, okay, formed from A to B as two adjacent sides. So the magnitude, so that is the magnitude of A cross B equals to the area formed by A and B, formed by the parallelogram from A and B. Okay. And the direction, you can see it's perpendicular to the plane formed by the vector. That's the direction of A cross B. So this is the new vector. So A cross B will form a vector perpendicular to both of them. Okay, the new vector. But okay, here of course we say perpendicular direction is this. So you can still have two possible directions. One is upward, another is downward. So we have to use the right-hand rule to fix the direction. Okay. So the direction is like this: A cross B to get. So if this is A direction, okay, this is B direction. How can we form A cross B? How can we determine the direction of A cross B? We need to use our right hand, okay, right hand rule. In the physics study, you are going to learn a lot of right hand rule, okay. So we already learned one, how to determine direction of I cap, J cap, K cap, okay. So similar to that, you need to put your hand in a way. First, you make your finger pointing to the first vector, A. And then, so if this is direction of A, you can put your hand in, still you can put your hand in different way. So you want to see in which way you can bring your finger to the direction of B. So if B is here, I have to put it this way, right? So I can bring my finger to B. If I put it this way, I cannot bring my finger to B. If I put it this way, I cannot bring my finger to B. So I have to put it this way so I can bring my finger to B. And then this direction is the direction of A cross B. Again, the right-hand rule, similar to IJK stuff. Okay? So the direction is that. So, and if let's say, and you can see here, one thing I would like to talk about is that from this right-hand rule, you can see that the vector product or the cross product is not commutative. In fact, it's anti-commutative. Because now because A cross B, if I do it, the direction is upward. But now if I'm going to do B cross A, you can check the direction. I have to point my finger to the direction of B, and then I can bring it to A. So it's downward. So B cross A is actually in the opposite direction of the A cross B. And the magnitude of course will be the same, okay? Because magnitude of B cross A will be B multiplied by A multiplied by sine theta. So these two are the same, but the direction will be opposite. So A cross B equals to negative B cross A. It's anti-commutative. Okay. So now we have some example of product mode operation where you don't have the normal commutative relationship. Okay, it's anti-commutative. In fact, this kind of extended operations are very important in the modern science, modern physics. In quantum mechanics, most of the operation is, many of the important operation is anti-commutative. Okay, it will produce a lot of new physics. Now, similarly, if we check the magnitude expression A multiplied by B multiplied by sine theta. So the value of A cross B depends on angle theta, the angle between the two vectors in the sine function Okay. So what happens is that if A is parallel with B, okay, if A and B are in the same direction, so the angle between of the two vectors will be 0. Sine 0 degree equals to 0. So in any case, if A parallel with B, A cross B will always give you 0 value. In this graph, you can see if A and B in the same direction, they're not going to form any parallel graph. Okay, so the area is just 0. Anti-parallel, you still get A cross B equals to 0. And if A is perpendicular to B, then the angle will be 90 degrees. In that case, sine 90 degrees equals to 1. So A cross B, the magnitude of A cross B is A multiplied by B. It gives you the maximum value. Geometrically, that means this parallelogram becomes a rectangle. Okay. And here, please note that we mentioned last class, in the analytical geometry, how can you determine two lines are perpendicular to each other? You try to calculate their inner product to see if it's 0. And similarly, how can you determine if two lines are parallel with each other? In fact, you can try to calculate the cross product to see if it's 0. Okay? So this inner product and the outer product are also very important when you started analytical geometry. Okay. Which is in, I think should be in calculus 3. Okay. So later we're going to see the example of the inner product and outer product. Okay. Many of the quantities, in fact, most of the quantities formed from either inner product or outer product in physics. Okay, you can see that later.